the next part of the program is a panel on differential privacy, obviously, but its implementation, deployment, and receptivity. And we have 4 outstanding panelists today. We have Rachel Cummings from Columbia, Anders Steele from Tonic.ai, Alexandra Korolova, haven't seen Alexandra yet. Yeah, she's there, great, from USC, and Kristin Tack. Now, let me tell you the rules of the game here. So every panelist will have 5 minutes for expressing their views on the panel topic. And then we'll move to about 20 minutes to questions that I have prepared for them. And then we'll open the floor for another 20 minutes for everyone to ask more questions. So without further ado, we're gonna start in the order which is listed on the website. So we'll start with Rachel for 5 minutes. Rachel, the floor is yours.
Fantastic, thank you. And I'm very happy being here today. It's amazing to see this come together again. Thank you so much, Nando, for your hard work, because I know that you have invested a lot into this and it's been a great event. So the question of bringing like a differential privacy into practice, I think that at least from my perspective as a computer science theorist, we tend to, in our community, think that like the reason why things haven't been like deployed enough is because we haven't built enough algorithms. And it's because we have like a log square approximation instead of a log. But I think if you're here on this call today, you agree that's maybe not the main barrier to use. I think in general, we have been doing great on the theory side in terms of like designing algorithms that have all these nice properties, and they have all these like approval guarantees. But I think that we also have to acknowledge privacy doesn't happen in a vacuum. And it's not just about designing the best algorithm possible, but it's about how are these things deployed? Who are the stakeholders? How do they feel about these algorithms? And these include a few groups, and I'll kind of like go through them briefly in my comments, and I imagine questions about these things will be raised during the panel. And the groups I'm going to talk about are the users who don't understand math and don't understand differential privacy. Are the lawyers who have to like kind of like regulate these things and like decide if they want to like use them. And then also, I know exactly what should I call them, but I'll call them kind of like corporate managers, decision makers. And the first group is a layperson. And we have to convince a layperson, I'm giving you differential privacy and this is a good guarantee. How are you going to do that? Are you going to make them listen to like, an hour-long talk involving a lot of like math and probabilities? Probably not. Are you going to tell them something that is very convincing, but kind of like not at all informative? For example, like a differential privacy is a gold standard. It's like, okay, and so that's great, and they might like it, but they don't really understand how are my data being protected in this process, and they're still not able to make informed like decisions about whether or not they want to share data. And then kind of on top of that, there's this question of kind of like how to pick epsilon. And this is relevant for kind of all three of the groups. And for the users, we commonly say on the like a computer science side that the like a choice of the epsilon should be left to the analysts to balance like privacy needs of the users and the privacy rights. The kind of like accuracy needs of the analysts and the privacy rights of the users. How do we quantify privacy rights? Well, we could ask people, how do you trade off between privacy quantified by like epsilon and some other thing that is important, whether that's money, or if it's like accurate analysis of your data, or if it's better personalization. And of course, we don't have the language to explain to lay people what is epsilon, and much less how should they reason about it. Is an epsilon of 0.5 good? Is an epsilon of 10 good? We don't have a way to kind of explain this to them in a way that can be understood by the layperson unless preferences can be elicited. And so we're kind of lacking all of this on the side of the users. And we are like presumably deploying differential privacy to protect them, and yet we don't have a way to kind of explain to them and elicit preferences from them about the use of their data. And like on the other two groups, lawyers, I think that we have to find a way to kind of understand how to make policy about like a differential privacy. And we currently have papers written, again, mostly by like computer scientists, and that is not the same way lawyers think about privacy. And again, this question of kind of like how to pick epsilon arises. What is a sufficient epsilon to guarantee legal protection? Well, we don't have a legal framework for talking about that, and so we also need to have a kind of like a bridge into laws. And then finally, on the like corporate management side, we have to think about the kind of incentives of the companies who are like deploying these tools. Presumably they're choosing to use differential privacy because they believe it gets them some goal. Maybe it's going to like enable them to like collect better data from the users if the users believe in their privacy and trust them more. Maybe they believe this is going to be legally mandated. Maybe this is like a PR appeal, and they want to like brand themselves as a privacy preserving company. Any of these things are possible, but those kind of like I describe at the high level, we should use DP, great. But then also, how do you go through, how do you implement it? How do you decide which DP algorithm do you use in your particular task? How do you decide, I have some constraints where I have to do like this thing exactly, maybe for like, accounting or legal reasons, and we saw this in the like census, how they were like constitutionally mandated to provide kind of like exact counts of certain things. But in companies, it's less clear what is required to be private and what can be done in the clear. And again, like the same question, how to pick epsilon comes up, and the companies can usually quantify very well the value of having accurate analysis in terms of their revenue stream, in terms of the value of the data, in terms of the value of the analysis, but it's harder for them to really quantify the value of privacy to the users. And so they're trying to do this kind of optimization question, but they're missing half of the problem. And again, they don't really have guidance in terms of like how do you pick parameters, how do you pick local versus central versus hybrid, how do you pick which algorithm do you use, how do you pick positive delta or no delta? All of these questions, as a technical community, we haven't really provided guidance, and I think exploring these questions over the next few years is going to really dramatically improve the ability of both companies and like governments to deploy these tools. Thank you. I think you're on mute, Pascal.
Was an interesting catchphrase. We're going to move to I think Ender at this point. Ender, the floor is yours.
Hi, thank you, Pascal. It's a great pleasure being here. I'm learning a lot from this conference and really enjoying the talks so far. So thank you for the opportunity, Nando and Pascal, to be here. So I'm Andrew Steele. I am lead data scientist at Tonic AI. We are a synthetic data company based in Atlanta and San Francisco. And we build tools for developers who need to take their private data, which they can't use in software testing, and make synthetic private versions of this. And some of the techniques we use are differential privacy. And so we're particularly interested in kind of the developments along these lines, and theoretical developments that allow us to make better synthetic data with better privacy guarantees. But to give you a little more context, right, so what are our customers? These are mainly software companies that are working in heavily regulated industries, think finance or healthcare. And again, their developers need to write code and test this against actual data. But of course, the data that they have, the production data, is all very sensitive, and so they can't use that. So we build these tools to make these synthetic versions of this data. Some of our tools, I mean, you can think about this as operating on huge databases. So many tables, say hundreds of tables or several databases. And of course, I mean, building realistic versions of these with realistic synthetic versions of these is difficult. Now, let's see, I think to answer the question of like what the status is or what the current deployment and implementation of differential privacy is, at least in our context. So we have certain tools which can take slices of the data, if you will, columns of a table or multiple columns, and generate synthetic versions of these with differential privacy guarantees. And we have, I mean, I think we find that a lot of our customers are primarily interested in like privacy from a like a generic point, but maybe not all of them know about differential privacy in particular. We do have some cases like financial companies that are private privacies and promises. We don't have people who know what a privacy budget is. We don't have people asking for a particular epsilon. And so that's part of the challenge, is figuring out how can we have these conversations with these companies and provide realistic guarantees of privacy. What are the kind of reasonable views of or reasonable values of epsilon? What are best practices here? And so, I mean, I have to admit, like I'm not an expert in the field like the rest of the panel. I'm coming from a background of mathematics and learning this material, and so I'm very interested in these types of discussions, but I can't really offer the authority of the theoretical background. So let me just say that I think there's a lot of exciting work happening in this field, particularly in the context of differentially private synthetic data, which we're very interested in, like in the small scope of a problem where you're trying to generate a realistic version, a realistic table rather than a realistic database with privacy guarantees. Then I think there's a lot of exciting progress here. So looking forward to hearing the other perspectives.
So thank you, Ander. I think we will come back to some of the issues that you are raising later on, probably because of the fact that you are mentioning regulated industries is actually pretty interesting, and I think that's something that probably we'll come back to in when I ask some additional questions. We'll move to Alexandra now. Alexandra, the floor is yours.
Hi, everyone. Thanks, Nando and Pascal, for the opportunity to be here. I've been learning a lot from the talks, and I'm looking forward to the discussion in this panel. I think we've made tremendous progress over the last 15 years, and especially in the last 5 to 10 in making differential privacy more practical and increasing the positive reception to it. So, and as evidenced by this workshop and the variety of work that we've seen here. Let me just focus on the couple of things that I think we're still missing. I think in academia, we tend to focus on picking very clean problems and coming up with very clean solutions to those problems. And that is very important work. But as we speak about deployment, what's needed is really solving not necessarily the clean, the sexy problems, but solving the actual problems that actual engineers or data practitioners have, and solving them in a way that fits into their existing data structure, into their data flow, that obeys all the constraints that they may have. So from my perspective, one of the things we're missing is really doing this solution for end to end of what is needed in practice and addressing all the possibly each of them very minor challenges, but challenges nonetheless to make it practical. The second thing that I believe we're missing is a lot of current solutions work very well for companies and entities that have a lot of data from a lot of users, and that also have a lot of engineers to dedicate to the deployment of differential privacy. And the next step that I think we should think about is how to make our solutions also usable to smaller companies and smaller data holders who don't have as much data and also don't have as much engineering resource to dedicate to implementing. And that focus could be both on relaxing definitions or guarantees, or it could be on building code bases that can be just deployed out of the box. But I think that's a direction that we as a community should think about. Thanks.
So thank you, Alexandra. I think you touched upon some of the points that I will be asking about in a moment. So so we'll come back to those points as well. So thank you very much. So we're moving to Christine to ask now. Christine has a couple of slides that she wants to talk over. So Christine, the floor is yours again.
Thank you. Thank you, Nando, and thank you, Pascal. So this is Nexus Research. We're a small R&D company located in the DC area, and we support the differential privacy efforts at the US Census Bureau. The technical lead for the NIST Differential Privacy Synthetic Data Challenges, and report co-lead for the UNC Blue Sky Thinking Network Synthetic Data Working Group, where we're collaborating with statistical agencies elsewhere in the world towards providing practical guidance on real-world use of privacy-preserving synthetic data. So we look a lot about what happens when you go to do these things in practice. In this talk, these few slides here, is only my independent observations as a researcher in the field. We're not speaking on behalf of any of our clients or collaborators. Okay, so when you go to do synthetic data, you discover how much you hate presenting in Zoom. When you go to do synthetic data, or any privacy preserving or machine learning sort of application, you're looking at deployment. That's about engineering a reliable, safe approach that will not conflict with data users' expectations in any catastrophic fashion. And there's a lot of considerations when you go to do this in practice as rules of thumb, right? You should test on a variety of real world data cases, not just one. You should look for difficult ones. You should intentionally search and understand failure points. Don't just rely on a single accuracy stat, but go looking for points in the data where there are problems. It's important to understand edge cases and post-processing. It's important to remember that this is all stochastic. And so if it works one time, it may not work the next. It's important to engineer for actual production. So when you've got lots of researchers collaborating and iteratively improving, there's a whole framework you need around them. Unit testing, issue tracking, configurability, or pretty soon we're all lost in a soup of differentially private spaghetti. And this is important because, as we know, if we do this badly, it can cause real world harm. But I've only got a couple minutes, so I'd like to talk about cars. I like reading 1920s detective fiction. And if you look at how the 1920s describe cars, it sounds a bit familiar. This was a new technology at the time. It was just reaching common use. It was powerful, useful, convenient, exciting, unpredictable, hard to control in bad circumstances, easy to crash, and not entirely trusted. In 1967, you may be familiar with Unsafe at Any Speed, written by Ralph Nader. And this began the whole idea of trying to figure out what sort of regulation and evaluation was necessary to get from theory to practice, to get from safer, more reliable, and better understood systems. So let's see, because we're trying to do that, let's see what it looked like when they did that. So that book and a report which was dramatically titled Accidental Death and Disability, the Neglected Disease of Modern Society, persuaded actually the creation of the US Department of Transportation, a variety of agencies and regulations. We started limiting what could be made in the US, and we started limiting what could be imported. And we ended up with the National Highway Traffic Safety Administration, that's the last time I'm going to say that, in 1970. And that has significantly improved results. What do? They test. This is what their testing looks like: vehicle performance, improved occupant protection, structural integrity, increased understanding of driver behavior, defects analysis that identifies and corrects safety-related defects. They have a variety of capabilities, and they break up what they're looking at into distinct categories. They have an immense amount of data. FARS has been operational since 1975. It's collected information from nearly 1 million motor vehicle fatalities. It translates those into 100 different coded data elements. So they look at failure cases. They don't just encounter them in sort of random research papers. That was kind of what led to that initial paper documenting the disease in modern society. But when you go to do this properly, this is just a small slice of the data products here. They're calculating and making it easy to access failure cases. From their evaluations, they figure out what works. And once they have done significant evaluation, they understand what's going on. What works gets written into law. And here are regulations. This is just a small sample covering everything from hood latches, windshield zone intrusion, bus emergency access, child restraint systems, complex real-world systems that have to function in real-world conditions, which are unpredictable or randomized. This is not nice crypto where we have simple deterministic proofs, but real-world things. We find a lot of tricks that work, as we're finding now in our papers, but you have to kind of go through and collect those. They got to keep up to date. So here is a estimation of potential safety benefits, pedestrian crash avoidance mitigation systems. So this is the thing that beeps when you get too close to something. You'll see this was April 2017. They're getting in on this pretty early. And this is just some samples of that report. It's a long report. They introduce a whole new testing approach for doing this. You can look at just some of the figures here. Adult walking the day with no obstruction, adult walking the day with no obstruction activation time. There's a variety of statistics they're doing and a variety of conditions they're looking at for robust evaluation. So what you have to realize, harm drives regulation, but regulation drives scientific advance, right? So the fact that we set these goals, the space race is a nice dramatic sort of cinematic thing to go try to achieve, but these count too. Advances in applied mathematics and physics modeling, materials science, sensors and AI, a much deeper and broader understanding of the sort of things that can happen in these big systems happened because we had these specific goals and well-formulated ways to go about them. And what did they do? They broke risk and harm down into clear categories. They maintained a clearinghouse of data on real-world failure cases. They identify, study, understand, document, and eventually regulate the technology. They rapidly develop robust new testing, and they write a lot of reports and some nice commercials. They get it out there. Okay. So as we move forward from theory to practice, we may want to consider what sort of support structures would best help us get there. And we should not underestimate the difficulty of getting things right. Or even think that, you know, the sort of mathematical tools that we have right now are going to be sufficient to get it right. And when you're trying to merge ML, AI with accuracy, fairness, and privacy, of course, it's even more complex. And requisite plug, please join us for this Differential Privacy Temporal Map Challenge if you'd like to see how you evaluate against some nice real-world problems on a nice standard problem set. So you can still join us. You get into, just give us a write-up by February 15th and get us running code by February 22nd, or please join us for the next sprint, which starts here in a month. Thank you very much.
So thank you, Christine. So this is a very interesting perspective, because if you think about transportation, both the car industry and the airlines are heavily regulated. But the software industry has not been regulated to the same extent, although at this point, they may even have a stronger impact on society as a whole, and introduce vulnerabilities that are actually even greater at this point. So this is interesting that there has been no regulation framework on software, on data, and so on. So it's a really interesting perspective. So let me go back to some of the questions that I wanted to ask you. And one of the things that I found very interesting is that it took some time before differential privacy was applied to the real world. But in the last couple of years, there have been a lot of success that have been reported. And I want to try to understand why this was happening, and whether this is because some of these companies had, outstanding engineers, like several of you have mentioned, or whether there were other reasons for actually using differential privacy in this setting. And so I think we have a very interesting group here of people who have collaborated with industry, who are in industry. And so I'm very curious to hear the perspective of why differential privacy has suddenly become used in significant fashion in industry. Anybody can take the question, obviously, and many can actually handle it, right? So take the floor if you want to.
Must it be someone on the panel, or could it be anyone?
Well, I mean, let's let the panel talk, but it can be, you can. I'll give you the floor afterwards as well. Yeah.
So
I'll.
oh,
go ahead, Christine. Go ahead.
Sure.
Go ahead, Christine.
So I'll jump in with an incomplete answer.
Yeah.
I'm sure Christine can say more. And the caveat is that I'm not in the industry. I'm an academic. I do consult and work part-time in industry on privacy teams. So I have kind of like a glimpse of that, but I have to admit it's very different from the world of academia. I mean, the answer that I always give when I get asked in my class, why is differential privacy the right answer? I tell them it's not the right answer. But it is a very good answer, and it's like the best one that we have after, now it's been 15 years since it was like introduced. And no one has found a better privacy definition that kind of like meets the same needs. Of course, we have slight variants. For example, there's like, central versus local, things like this, but it's all kind of like in the same DP family. And I think that it has a lot of nice properties that we want our privacy guarantees to have. For example, it has post-processing, it has composition, it has group privacy. All of these things are nice. I truly don't know why it has blown up in the last maybe like 5 or 10 years. Perhaps like someone else can say kind of like specifically why. I mean, my guess has always been people finally realized it's nice, and we then have enough algorithms and like enough engineers who can actually build it and can like understand it. But that sort of doesn't say why now specifically is it happening, and why not in 3 years or like happening earlier.
Yeah, or sorry, please go ahead.
So I think one important caveat is that there are, I think, more papers from industry talking about applications of differential privacy than there are differential privacy tools actively in use in core systems in industry. So yeah, I think it's more accurate to say that industry is investigating it and considering it, and they're interested in it, rather than that they're massively adopting it yet. For why they are interested, and I'm sure you have, we work mostly with government agencies, so I will say I'm hypothesizing here, but census ran into it, right? Because there's a massive amount of data out there, but they have to legally prevent re-identification. You look at GDPR, and you've got a similar sort of problem you're running into, and there's other sorts of privacy regulations now that are making it so that this may be a requirement in the future, and that makes it like this is a good time to start investigating it. That said, you've also got companies who, have money to sink into R&D, and this is an interesting thing for them to investigate among the many things they're investigating. So go ahead.
I think that's great. And I think there's also a growing awareness of privacy issues, outside of the, just, well, in the public sphere at large. I mean, we have things like the de-anonymization of the Netflix challenge data as, a well-known example of failures of privacy techniques. And of course, differential privacy is a very appealing framework for working and addressing some of these cases. And so I think that drives some of the interest. It's kind of the growing public awareness of these privacy issues. I mean, like the Equifax breach being another good example. From my perspective, it seems like consumers in particular are becoming more desirous of privacy guarantees, and I think software companies in particular are becoming more sensitive to these concerns.
Let me also add a few words. I think there's 3 reasons why in the last maybe 5 years there's been a lot more deployments and conversation in industry. And 2 maybe can be attributed to what this community has done, and 1 maybe is out of our control. I'd say the first thing is that faculty have been teaching differential privacy, have been teaching attacks and explaining why other solutions don't work to now a generation of students who have then gone out to work in industry. So one reason is that we now have a much more informed employee base who know what are the challenges and who know what are the potential tools to be taken to address those challenges. Another reason could be that Google's report and then Apple's deployment of differential privacy has demonstrated that it's actually not just a theoretical construct, but it's feasible to use it in practice. And once there's one demonstration or 2 demonstrations that it's feasible, then others also feel empowered that this may be feasible for their use case. And the third change, and this is maybe a cynical take, but the tide of public opinion on data use and privacy has changed in the last few years. And now it serves companies' PR interests if they can say that we are using state-of-the-art privacy protections. So perhaps another reason for the change is that it's good for PR. Thanks.
So thank you, everyone. I think it's always interesting. You have a panel with 4 different people, and you get the union of the ideas is much greater than what you expect. So it's always very interesting. Adam, you wanted to say something about this topic?
I was only going to make a very non-technical observation. I work with Andrew at Tonic, by the way.
Yeah.
2 or 3 years ago, when I was in sales calls with potential customers for Tonic, differential privacy never came up. And in the past 2 years, we see it come up more and more often, which is just maybe a fun data point for the folks in the room.
Yeah, thank you for that data points, since we're talking about data, right? So let me move to different topics. I mean, it has been alluded to by several of you already, but I think, and I think Christine just mentioned it. I think the key point is that when you want to use differential privacy, it's not obvious that you have many algorithms, you have very few tools that you can actually use, and they are not necessarily adapted to the particular situation. So, do you see any hope that this will actually be addressed, or will it always be, I need to look at this application, I have to understand it, all kinds of details before I can deploy differential privacy? Are we going to get at some point some level of automation in deploying differential privacy? This is a long silence.
Sure, I'll say something. Although I think Alexandra and Rachel both had insights on that. But my personal opinion is that we're a long way from automation that will produce really reliable, useful results that won't have problems with bias or fairness or unpredictable behavior. That said, I think we can get there, but we need to have a much deeper understanding of what's happening. Again, when you take that accuracy and you just give it a single little number that said, oh, I did this accurate, you're not looking at anything like the detail of how it's treating different sections of the data, how it's, treating different sort of contexts. And so we don't know where all the levers and knobs and dials are. We don't have the information we need to be able to automate safely. We don't even have the information we need to be able to tailor it necessarily very rapidly. Yeah. That said, I think some simple solutions, just, Laplacian noise, stuff like that, those are accessible to go understand and automate and get out there and they cover a lot of use cases. So yes and no, there's my answer. It's a good panel answer. All right.
Rachel.
I agree that we are a long ways from that. I think that is, of course, the ultimate goal is to have a kind of engineer at a company think, I want to do this privately. They go out and they download the library and they just run it and they trust that it works and it's going to be correct and it's going to be private and it's going to be fair and it's going to be all these things. That's definitely the goal, but we are a long ways from that. And this is something I think Alexandra mentioned in her opening comments, is that we need an open source library containing the most important DP algorithms and some that are more specialized. And we currently don't have that. There are a few groups assembling these libraries. There's a group at Harvard doing this, and the privacy tools project, OpenDP and on DP.com have some of these things, but they're very far from deployment ready at scale, and it's more kind of a sandbox for researchers to play around in. And they don't have every algorithm you might want. They have some. They certainly don't have kind of everything. And they view that even as a first step, and then kind of as a more advanced step before we deploy things. Some of the topics Christine mentioned, bias, fairness, are we treating different groups differently? Especially when you talk about synthetic data, there's a huge kind of educational challenge. How do I convey to a person, this is fake data, it's not real, and you shouldn't go in and treat this is a row of this person with these attributes, because that's not what synthetic data gives you, and a kind of understanding of the accuracy guarantees that are inherent in that, especially surrounding differential privacy. I think things like that have to be addressed. And again, that's definitely the goal, but we are many years from that state.
Yeah. Thank you, Rachel. Let me ask Ander also to comment on his experience in industry working with different customers. So does it mean that every time you have a new customer, so you are really redesigning new algorithm? Can you reuse from one customer to another one? How does it work at Tonic AI?
Yeah, so we have a lot of tools which are, as Christine suggested, Laplace noise works well in many situations. Gaussian noise works well. So we have a lot of reusable tools for kind of synthesizing slices of data with differential privacy guarantees. That said, I think customers that are looking for more sophisticated synthetic data, like for applications to analytics or applications to machine learning, I think we're still, in general, far away from having a black box solution. Now, there's a lot of exciting progress in this field. Things like DP AutoGAN are very compelling. The idea of having a generative adversarial network that you can just feed in a table and that, a privacy budget, and then later spit out some synthetic version. I mean, we're not there yet. That still requires a lot of fiddling, a lot of knobs, a lot of engineering. But that said, I mean, if you look at the progress of GANs over the past 6 years, 6 or 7 years, like the amount of progress that's happened in that area, just in the deep learning area of like building, higher and higher resolution images of realistic looking data, makes me optimistic about kind of the parallel development of these private techniques. But again, there's still a tremendous amount of challenges there.
So thank you, Adam. Ander, sorry. I would like to open the floor to the audience. I have more questions, obviously, many more, but I also would like to open the floor to everyone. So if you have questions, don't hesitate. Put them on the chat, or just ask the question. So let me build on one of the things that Ander just said, which is the fact that in general, once you move to specific analytics tasks, the whole process becomes more complicated. And I think it's certainly related to issues that Christine and Alexandra have talked about, and Rachel, in terms of fairness and bias. So can you address that issue, and how you think we should go about explaining to people the difficulty? It's not just making the data private. You have some restriction on how you use it because of how the data is being actually produced. So what are your views on educating the public, and even people who are actually sophisticated from a technical standpoint, on the fact that this data has some properties, and you have to be careful?
Yeah, I think that's a great question. I think it's important to educate, in particular, consumers of synthetic data of the limitations. And I think there's sophisticated consumers of synthetic data are aware that this is maybe not where they're going to train their models. This is where they're going to test ideas. This is where they're going to sandbox ideas. And of course, you do have to think carefully about the issues of fairness. You do have to think carefully about, is your synthetic data capturing the tails of your actual data set, or are you just capturing the obvious thing? I don't have a good answer, but I think it's definitely important to communicate these things to the consumers of these data.
Go ahead, Christine. Thank you, Ander.
So I have, so first of all, this is my plug for, please check out the NIST Differential Privacy Data Challenges. We have one going right now. And in there, the goal really is to be able to make this sprint and potentially next sprint synthetic data that's of sufficient quality it can be used for analytics. That said, right now we're tackling sort of accuracy. We use K-marginal and some other things for evaluation. We're not tackling the bias and fairness issue at this point. And I think where you run into it, and Ashwin mentioned some of this yesterday, is when you have algorithms that do interesting things with post-processing, or do interesting things to constrain the data space, or force some sort of model on the data, or some other thing, where, because every time you check the data, you're incurring the sensitivity cost, you're adding noise. So when you go to try and get accuracy, you find ways to touch the data less and less and optimize the data space you're working with. When you do that, you can have an effect on fairness and bias issues, right? You can be altering and distorting the underlying population distribution. And I think this needs to be understood and fixed. I think it's not something that we can communicate about necessarily until we understand it. And once we do understand it, I think we've got a reasonable shot at fixing it. So this is how I ended up showing you lots of slides about cars. Because when you have a big complex system, you're trying to get it to really work for real and not cause harm. There's a significant lift that goes into getting that all going. And I think if we want to do this for real, which I think we can, I think we've got that ahead of us. We get to navigate it somehow.
I think that's a very good point, that it took a long, long time to actually get to regulation for the car industry, and that we should also be patient, and that this is not a process that will get there in one step. Although, you know, we live in a world that is much faster than it used to be. And therefore, I mean, it's some of these issues are more pressing because the consequences are already upon us on how people are using the data. But it's a very good point. I mean, what you communicate is the fact that there is a lot of work to do. Rachel, you wanted to add something?
Yeah. I want to draw maybe like another comparison into something else in practice that we like understand. I think the nice comparison is to something like a bridge, right? And so like in terms of a bridge, as a layperson, we understand what we want of a bridge. We want it to not fall down. That's it. But of course, if you are a civil engineer, that becomes a much more nuanced question. Not fall down under what weight, under what weather conditions, blah, 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 blah. And then there's a question of kind of like, you know, how do you build a bridge that meets these like conditions? Do you use concrete? Do you use steel rebar? How wide should the base be? All of those things. Like as a consumer, you don't have to think about those. You just have to like trust they have standards and they have experts who are building things to the appropriate standards so that my needs are met. And my needs are very simple. I want to not have a bridge collapse. That's great. I think in privacy, we want to draw the similar analog, only we're kind of stuck in the question at this stage. I want the bridge to not collapse under what weight and what weather conditions, and is it robust to like earthquakes, right? And so we're still trying to like understand, we want privacy and we want accuracy. What exactly does that mean? And I think that we have all the tools to build bridge supports of the appropriate diameter with the appropriate building tools, right? And so these are like a differential private algorithm. So we have those, and we're just like not entirely sure what are the specifications to which we have to build our bridge. And so I think a lot of the parallels to things Christine mentioned are there in terms of what we're missing. We need a clear understanding so that when people say, I want privacy, I want accuracy, we can translate that into kind of like a simple checkbox, yes, no, I have done it. And we're not really at that stage yet in terms of saying like privacy check, accuracy check. We're still kind of like figuring out the details and the standards. And I would love to see in the next few years some kind of standards for differential privacy and for the accuracy that results from it, because there can certainly be harms happening if we have too much privacy, and that leads to kind of like inaccurate analysis, which are then used in kind of like a real world, like a decision making processes. And so I think that we want to regulate both privacy and like accuracy as well. And there has to be some kind of like a contextual understanding. Privacy in this context means blah, privacy in this context means blah. And we don't really have that framework yet. But I think that is very much.
This is a really great analogy and great point, Rachel. I think what you're looking for is kind of a risk and reliability framework or assessment, which many engineering disciplines have. I think the challenge for the area is the fact that we are dealing with a piece which is much more powerful than a bridge, because as soon as you release data, it's very difficult to anticipate how it's going to be used. And I think this is I think part of the challenge here. Although differential privacy has some really nice aspects to actually tackle that challenge, but it's very difficult to anticipate how people are going to be using the data, are using the algorithm, and that's what complicates everything. So we have to wrap up now. I think we could have continued for another hour. It's a very interesting panel, and I think at least I got a lot of interesting metaphors and pointers for a subsequent panel, maybe next year. So I'd like to thank the panelists, everyone, Rachel, Christine, Ander, and Alexandra, for very interesting insight. I learned a lot. And so I want to thank you very much for sharing your thoughts with us. It's not always easy to be on a panel like this, but I think it was pretty well done and pretty interesting. So thank you very much. The next session is going to be a poster session now.
Questions too.
Yeah, thank you, Rachel.
Yeah.
And we'll reconvene at around 5 p.m. For concluding the workshop. So again, thank you very much to everyone. I think this was really interesting. Thank you for preparing this, this panel and for participating. We really appreciate it.
Thanks for organizing.
Thank you, Alexandra. Thank you, Christine. Thank you, Ander.
Thank you, Pascal.